The work done to raise a mass m from the surface of earth to a height h, which is equal to the radius of earth, is. So our aim is to find out the value of work done to take an object of mass, let's say m, from the surface of earth to a height which is equal to nothing but the radius of earth. So we can use this concept that work done is equal to nothing but change in kinetic energy plus change in potential energy. Over here the kinetic energy is not changing, so we can just write the value of work done is equal to change in, or work done by this external is equal to change in potential energy. And we know that change in potential is final potential minus initial potential, and the final, let's say this is our final point and surface of earth is our initial point. So final potential, we can try it. Let's see, final potential is not equal to mgh. Final potential is minus of gmm divided by, we need to measure the distance from the center, that is equal to 2r, minus the value of initial potential, which is not 0, that is minus of gmm divided by r. So we can write the value for it, that is gmm divided by r. If I am taking it as common, this is minus 1 by 2 minus minus, it becomes plus. So we can write 1 minus 1 by 2 is plus 1 by 2. So we'll get the answer as gmm divided by 2r. But you can observe that it is not given in terms of the universal gravitational constant, but it is given in terms of radius of earth as well as in terms of acceleration due to gravity. So just to write it in terms of acceleration due to gravity, just multiply and divided by r. So we'll get one term as gm by r square, and we know that this gm by r square is the equation for acceleration due to gravity on the surface. So we can write this as m g naught into r divided by 2 is a value of change in potential energy.